Hello everyone, welcome to the session 3 of the 2024 APRU SWM Global ESG and Sustainability Lecture Series hosted by the APRU Sustainable Waste Management Program. Today's lecture will be delivered by Professor Alex Godoy-Faúndez from Universidad del Desarrollo. Following the lecture, we'll have a panel discussion and a Q&A session. I am Samhita Ankareddy, the moderator for today's session, and I am also a PhD student at Korea University. Before we begin the lecture, I would like to give a brief introduction to the APRU SWM program. The APRU Sustainable Waste Management Program is an integral part of the APRU membership and consistently works towards achieving the UN SDGs through thoughtfully designed events and programs aimed at raising awareness on sustainability, the UN SDGs, and the concept of ESG. The 2024 APRU SWM Global ESG and Sustainability Lecture Series commenced this April, and the first two sessions drew audience from various geographies with diverse expertise. We encourage you to look forward to today's session as well as the upcoming sessions, participate actively, and engage with us further. You can find more information on our website regarding speakers and registration. Moving to today's session, Professor Godoy will discuss about circular economy challenges within a global supply chain framework by giving an intercontinental perspective. Following the lecture, Professor Godoy will engage in a discussion with a panel of experts, drawing on their expertise and geographic perspectives. Before we dive into the session, I'd like to give you all a brief about our speaker. It is my honor to introduce Professor Alex Godoy-Faúndez, an expert in sustainability science. Professor Godoy-Faúndez is the director of the Sustainability Research Center and Strategic Resource Management and the academic director of the Master's Program in Sustainable Management at the School of Engineering at Universidad del Desarrollo. He also serves as a research associate at the Water Research Center for Agriculture and Mining. Professor Godoy-Faúndez holds significant roles as the head of Waste to Energy Research and Technology Chile and as a research associate at the Earth Engineering Center at Columbia University. He was a visiting scholar at the University of Wisconsin, Green Bay, and Harvard University previously. Throughout his career, he has actively participated in advisory boards for various governmental institutions, including National Commission for Scientific and Technological Research, the Ministry of Finance, and the Ministry of Environment. In 2015, he was part of the Chilean delegation for COP21, advising the Ministry of Finance on the Paris Agreement, and in 2019, he served on the Scientific Committee on Climate Change for the Ministry of Science, Technology, Knowledge, and Innovation, organizing COP25. His research endeavors focus on understanding the complex interactions between engineering, society, and sustainability. You can also gain insights into Professor's latest research and publications by searching for Professor Godoy-Faúndez on Google Scholar. At the end of the seminar, we'll have a panel discussion and a Q&A session, and I request all of you to actively interact with Professor Godoy and our panelists. With this, I would like to extend a warm welcome to our speaker, Professor Godoy, our panelists, and our participants. Without further ado, Professor Godoy, the floor is all yours. Thank you.
Thanks for your introduction and welcome to Professor Can Lee and Gomez Paredes. I apologize because I come from South America, so my accents could be a little different. So, but I will try to pronounce more flat. Let me share. I would like to start my presentation to discussing about the challenge in circular economy at the global level. Okay, so I would like to explain in just 30 minutes now what are the circular economy challenge, because sometimes right now in South America and after the plastic treaty in Ottawa, we are discussing how we can circularize the plastic, or we are talking how we can remove some specific chemicals from the economy. But this is very complicated, because I would like to start talking about the climate change. Why the climate change? Because right now, circular economy is one of the main approach to trying to reduce the carbon footprint at production level and trading and so on, and manufacturing and so on. Right now, we are on the track on the limit to 1.5 Celsius degrees. Indeed, and according of the last report from NOAA, the United States, we have an 1.6 Celsius degrees over the industrial age. So right now the warming is unprecedented in more than 2,000 years, and right now nobody discuss about that. We are observing that the simulated and human and natural trends are showing that the human beings, we are the main drivers right now, and moving to the climate change. So, but the problem is and how we can decarbonize the economy. And one of the classic approach is the electrification and always renewable energy based on solar, wind, geothermal, or other ones. But the problem is not that. The problem is all industrial system is based into the non-electric and sources like gas, natural gas, and so on. So the problem is how we can reduce or how we can decarbonize the land transport, the coal plant, the industrial processes, because finally 60% of the carbon emission depend on the non-electric sources right now. So if we want to reduce that, we need to understand that the largest sources of the global warming pollution is the burning of the fossil fuels. Why I'm not talking about the fuel oils and not the circular economy is because finally the carbon footprint depends on the demand of the too many goods and services provided by the global south mainly. And because in the global south we are extractive and too many raw materials and the global north. And finally, this and global pollution is a signal that is a signal or in other words is like symptoms about the material flow between global north and global south. So the problem with the climate change is every time the weather is more hot and throughout the time, and the next year maybe right now this 2024 will be the more warmer year in the last 40 years, and finally this is correlated with the increasing of the ocean temperatures and setting new records. So. The problem is the 19 of the 20 hottest years on the record have occurred since 2002, and indeed the last 10 years appears from the 2014. So the problem with the climate change is independent if we are located in the global north and the global south, the people is so vulnerable to that. But the labor conditions in the global north are not the similar conditions in the global south. So one of when we are talking about the circular economy, the problem is always we are thinking in the circularization, but we are not thinking that we need too many facilities or we need too many investment in infrastructure to provide the right infrastructure for the people working in the global south, because finally it's these people that extracting raw materials and importing too many goods from the global north, but these people maybe needs more and more investment for adaptation indeed. So if we take in consideration that who is the most vulnerable people to heat, and the most vulnerable people is the poor and homeless, elderly people, infants and children, and those with the pre-existing medical conditions, particularly with the cardiac and respiratory conditions, mentally ill, agricultural workers, outdoor jobs, and so on. Indeed, the recycler is one of the most vulnerable people and affected by the climate change. So the problem is that right now the temperatures are occurring in different parts of the world, and every time we are more and more hot than previous years, exceeded maybe 50 years in some countries like Iran, Kuwait, Oman, and Emirates, or in Europe, for example, in 2022 it was the hottest year on record in France, Germany, Netherlands, UK, Belgium, and Luxembourg. So, but we are not seeing. This is how we can connect in the dots between climate change, circular economy, and material flow accounting, demand, production, and so on. Is the missing link between adaptation and mitigation by shaping supply chains. This is the main problem, because it's, and we are not seeing that right now. That, for example, one specific products, for example, from, I don't know, and I would like to produce one name, and Apple. Apple, maybe the headquarters and is located in Cupertino in California, but they are not manufacturing nothing. Indeed, they have a global supply chain, and the manufacturing is in China and in the south of Asia, but the factories there are importing too many raw materials, specifically, for example, rare minerals or lithium or copper from the South America and from the South Africa. So this kind of countries that not appears in this picture is they're exporting too many minerals and metals to the factories in the south of Asia, connecting both countries by driving by the demand, global demand by laptops, computers, and so on, by connecting them between different and flows, the materials in the globe. So the problem is the climate change is affecting and for example the water availability. Right now we know that reducing supply and decreasing demand, and we are reduced supply like runoff, drought, by melting ice and so on, and the decreasing demand by industry, domestic agriculture and so on. But the problem is this kind of natural hazards is impacting more in the countries that are extracting raw materials. Despite of the impacts of the climate change is distributed through the world, particularly in the global south, the impacts of these issues could be worse than in another side. And so when we are increasing the temperature, we're increasing the evaporation, and the evaporation increasing the precipitation and increasing the level of the sea, impacting the hydrological cycle. And this is because every time we have more and more global record-breaking precipitation anomalies, drought or heavy rainfall and throughout the world. But the problem is that this is kind of natural hazards. Is impacting more in the more developing countries, in the middle-income countries, in the more vulnerable and poor countries, and all these kind of countries are extracting raw materials from the manufacturing countries in the global north. As the temperature is increasing too, we are increasing the evaporation from the oceans and from the land, and impacting the food, for example, and by drought. This is one example in Corrales, New Mexico, where the NOAA predicts prolonged and widespread drought and warmer and drier than normal spring for most of the country. This is Mexico. In Mexico, nearly 85% of the country is experiencing drought conditions, and maybe beyond of the last 30 years. Iran, 97% of the experience and severe drought in 2018. Or Poland, some parts of Poland, Romania, the drought was the worst in a century. Indeed, for the Czech Republic, it was worse in the 500 years ago. So the problem of the water decreasing and the water scarcity and the warmer temperatures is affecting the food, impacting the nutrition, storm, drought, disease, heat, and so on. But finally, they are impacting the food production too, impacting the different climate and hazard are impacting on different parts of the food supply chain by reducing the crop yields and increasing the price of the food price index. And for example, in corn, have reduced in 7.4% with 6%, rice 3.2%, and soy and soybean and 3.1%. So the climate change is impacting to the most vulnerable countries and extractive economies by climate impacts by different kind of disasters. They're reducing, and they don't have the money to face the water scarcity. They don't have the money to increase the crop yields, but the demand for this kind of products is continuing increasing through the time. This is the problem, how we can connect the extraction of the raw materials, the productions, and the demand and the consumption. And the consumption right now, we know that the 20% of the population in the world, maybe the most rich people in the developed countries, maybe they are driving the demand for too many and raw materials, including food. So, for example, this is the profile of the annual water demand for different regions. And here you can see in China, for example, the main demand will be by industry. This is of course, because finally the demand for the industry is because too many factories has been located there. But it's completely different for India. In India, maybe the agriculture is the main sector demanding water, and to produce food for 300 millions of people is the same for sub-Saharan Africa, of the rest of the Asia. In the case, for example, in the South America, like South America, the agriculture is demanding and maybe the half of the total water that the industry needs, because we are exporting too many products like fruits and vegetables to the global north, by including minerals and metals like copper, lithium, so on, demanding every time more and more water. And the problem is the countries in the South America and in Africa, they don't have money to try to alleviate the impacts of the climate change or start to the transition for the adaptation to the climate change. So what I'm trying to say, once is the consumption. The consumption is the main drivers and to increase the production, and the production is increasing the extraction of raw materials, is the extraction of the food, and finally the supply chain is a global supply chain, but nobody is thinking that how we can and understand this kind of complexity, because for one side we need to reduce the consumption, but the consumption depends of the number of the people in any country and how the people is increasing the incomes for the time. But on the other side, the production, and when we are talking about the productions, we are in the same bags, people extracting raw materials and the people manufacturing goods. It's completely different. It's completely different, because finally we have a strong relation between economies in middle income countries or low income countries extracting raw materials continuously and starting and increasing the price for themselves and exporting this kind of the materials to the global north for the manufacturing countries, because they're manufacturing too many advanced and too many products, and exporting these products for the global south again. So we have a circle, and this is because we need to understand how we can and deploy and write strategies of the circular economy to try to recover too many materials and so on. And for example, and when in my case in Chile, we are producing lithium and copper right now. We are extracting lithium and copper, exporting the lithium and copper for Europe, for Europe and United States and China, and they're converting them in batteries, in cars, and they're exporting the cars again to the global south. We are importing electric cars. They're so beautiful indeed, but the problem is we don't have the facilities and the people or the capabilities and the skill to try to recover lithium from this kind of cars, or for example recovering copper. And if suppose that I can recover the copper or recover the lithium, I don't have the demand from the manufacturing countries to buy that recovered lithium or the correct copper. So suppose that if I am recovering copper in Chile, we don't have the buyers of this kind of coppers to circularize the global supply chain, and this is the main problem. So, and in this case, for example, the problem is worse. Right now, we know that the food surplus and deficit, and the deficit of the food is going to the Central America, Africa, Western Europe, and South Africa. But finally, the deficit in this kind of countries, because is a net balance between global south and global north. And finally, in South America, for example, and Central America, we are exporting and the food for the North and the surpluses of the South America is exporting to the North America and Europe to trying to and increase the income of our country by new market. But the problem is the food security in the rich countries depend of the food security in the low income countries. This is, for example, one example. This is the tree cover loss in 2020 in Brazil, Congo, Bolivia, and Indonesia. Is because in Brazil and the Congo, the deforestation is driven by the demand. What I'm trying to say, and for example, the demand for the meat and for the meat depend of the rich countries. And in Brazil, the deforestation is driven because the farmers, and as they are facing the drought scarcity, they need to expand the farm by reforestation, expanding the size of the farms to trying to get more cows, to try to provide the production of the meat for the demand. But the demand is not for Brazil, the demand is for rich countries. So this kind of trade-off we need to understand, and before to deploy the new kind of strategy for circular economy. We were working on 3 years into the DC and committee into the ISO standard to try to understand what are the complexity for the next ISO standard in circular economy. And one of the main challenge is how we can circularize the process and throughout the world when we have the productions, the manufacturing goods in China, also that on South of Asia, we have materials recovered in the global South, and how we can return this kind of materials and the factories plant, but we don't have right now the right response for that. So when we are talking about the extend the EPR law or extend the producing responsibility, the question is who is the producers? Suppose that if you are buying a Mac and laptop computer, you are designing the computer in United States, but the United States nobody is manufacturing the laptop, is manufacturing in the South of Asia. So who is the producer? Who have the responsibility for that? This is the yearly deforestation in the Amazon. And this is deforestation in Indonesia, just for palm oil. And the palm oil is a key oil for too many food products used for Nestle and the big brands. How we can replace that? How we can circularize this kind of process? Or for example, in Mexico right now we have the deforestation is driving for too many farmers expanding the size of the farms because they need to produce more avocados. And the avocados is a very tasty product from Mexico because they have a huge consumption, but they know that they are exporting avocados to United States because every time you have more and more population from Mexico living there and introducing the Mexican food. All people are enjoying Mexican food, but the problem is we need we need to deforestate too many areas to try to provide the right quantity of the avocados according to the demand. How we can solve that? This is the main discussion with my colleagues. Indeed, the problem of the warmer oceans is because the nutritional quality of the ocean fish decrease throughout the time when the temperatures go up. So, for example, in some specific places in the United States, the oyster farms on the United States and in the West and East Coast has been hurt by the ocean acidification, threatening 1,000 jobs. But this is not just in the United States. Right now, we have more and more evidence that in different countries producing oyster farms, producing shrimps or another kind of mussels or seafood. The problem is in every time the producing is go down, indeed, because every time the acidic water is higher, so they are dissolving the shells of different mussels and from the food. So finally, the capacity of the extractive economies to produce food or extract minerals for the global north every time is less. So the problem is why right now we are driving the poverty too. So the problem is with we have a very good correlation between temperature and fires, and this is another big climate hazard because finally the temperature when the temperature is going up, the number of the fires is going up too. The problem is the fires is affecting the farmers. So The farmers are impacted by warmer weather. They are impacting the suffering drought scarcity, water scarcity. They are impacting because the fires is impacting to them. So who pay for that? Because finally the raw materials extracted in our economies is not for us, it's for the external market. So, and this is, for example, the worldwide extreme weather catastrophes, according of the Munich Re. This is a company and taking the numbers and in insurance. Here you can see the number of events of the storms, floods, mudslides, extreme temperature, drought, and fires. And every time this kind is higher in the middle and lower income countries, and all these kind of countries, they are extracting raw materials for the manufacturing countries in Europe or United States when in China. And this is, for example, this is a very good case, and the economic losses from the climate change. This is just for United States, and here you can see how much money the different insurance are paying for the American companies. And here you can see the main drivers of the climate hazards and driving the economic losses are flood and storm. The question is, what are the main climate hazards for South of Asia? What are the main climate hazards for South Korea? What are the main climate hazards for Africa and South America? Because this kind of climate hazard are impacting directly the extractive system to keep an wealthy economy. So indeed, if we don't work on the adaptation process, we are expecting that Brazil lost 17% of the GDP, Colombia 22%, and Chile 27%. So the problem is the demand. Right now, we know that we need to change the transport and public transport all the time by reducing the demand and increasing the low carbon technologies, because this kind of technologies, they need to reduce and it's needed to reduce the emissions. We need more electric vehicles, and we need more batteries, and we need to a new kind of engines for aviation and shipping and so on. And indeed, right now, in 2015, 40% of the world buses will be the electric buses. And this is the case, for example, for us. We are importing too many electric buses. This is Santiago de Chile in 2018, but it's the same for Colombia. You have more and more and public transport based on electric buses. This is Sao Paulo, or in Mexico City. This is all middle income and emerging economies. But indeed in China, for example, 1 year ago installed 112,000 public electric and vehicle charging station. And just in China, we have more than 800,000 public electric vehicle station. This is right now in the test Tesla semi-truck. This is in one truck right now. Maybe I think so in the next year we'll be operating in Europe and maybe in South America. And already in Germany we have just trucks just using hydrogen, and it's so beautiful news. But the problem is the demand of the critical materials. In energy, for example, the major transition for electrification, because if we have electric cars or we need to produce hydrogen, we need to produce energy, and the energy needs to be converted in electricity. So the problem of the electricity, they are using the same and rare and the same and minerals and metals, and this is the global wind energy capacity and today, and this is the cost of the onshore of the wind turbines all the time. Right now is cheaper than before, and this is the capacity to generate electricity just using sunlight from Latin America. And the solar and PV installation is going down every time. and the cost of the crystalline silicon solar cell modules is go down through the time, so it's more expensive. But nobody's sorry, and indeed, over 290 global companies have made a commitment to go 100 renewable energy, and all these kind of companies are buying an electricity and clean electricity. The global corporate clean energy purchase agreement is going up every time. And this is the price of the lithium-ion batteries that is go down all the time too. And this is the global commodity and storage capacity of the batteries. And this is what we're expecting from the future, and this is the forecasting demand. So all people know that we need an agricultural revolutions, we need an industrial revolutions, and we need a digital revolution, and we need an sustainability revolution. But the question is, who pay for that? So we need to understand the missing link between adaptation and mitigation, because finally the most vulnerable countries are countries producing food and producing minerals for the green transition. It's the people living maybe middle income in the world that suffering the impacts. Indeed, right now we have more demand by the minerals by China, and indeed China invests $2 billion, $2,000 million in Zimbabwe 1 year ago. The European Green Deal is buying lithium and copper and try to keep the safe flow of the food for the future. And right now, the Biden administration, by the new law, the IRA, the Inflation Reduction Act, is increasing the pressure on the natural resources extraction in the global south. So the problem is how we can manage and how we can and deploy and the right circular economy in this scenario. For example, this is the market of the lithium, for example, in the global supply, future demand and prices. Here you can see the consumption is going up through the time, but the production is not clear. And every time in 10 years ago is maybe an half to half. The problem is the material flow accounting, the ore and brines to the lithium in different and linking importing countries and importing and exporting countries. The problem is what kind of products we need to produce and we need to drive in the demand for all countries. And finally, we need to understand how could be the complexity of the world trade materials and the world and the material flow accounting in the globe, and producing or driving the demand by minerals, chemicals, and products. Because finally, the impacts of the extraction and the impacts of the climate change into the most vulnerable country, and we create poverty, inequity, and so on. Meanwhile, the rich countries, they are driving the demand by consumption, importing the goods and the raw materials from the global south. The problem is the environmental impacts of this extraction will be leaving behind. So this is, for example, the minerals, basic chemicals, derivative and derivative and by lithium batteries. And right now, the complexity every time is worse. The question here is how we can circularize this kind of flow. We can understand very well that what kind of countries are extracting lithium, metals, and so on, and what kind of countries are importing them. But how many countries they are exporting too many products, batteries, and so on for the rest of the world, and how we can recover the materials to try to reduce the environmental impacts by extraction. For example, in here, this is a very good map about the consumer electric vehicles and energy storage systems. And it's interesting because maybe 3/4 of the total productions and of the application of the different lithium batteries is just in portable computers, in consumer electronics, batteries, small batteries, and so on. In just maybe 1/3 of the products are just electric vehicles. So this is, for example, another interesting graph. This is, for example, the tracing production carbon emission transfer between the demand and the producers. And here you can see that in red, maybe we are despite of all people know that the greenhouse emissions is higher in United States and China, The problem is maybe huge quantity of the greenhouse emission is based on the natural resource extractions, because the economies in the extractive economies in the middle income countries and low income countries, they are based in fuel oils and machines, and the capacity to replace this kind of the technologies maybe is not the same as the capacity to replace the old technologies in the rich countries. Indeed, the rich countries are producing too many technologies that right now in the global south we cannot buy to reduce our greenhouse emissions. For example, this is the carbon dioxide embedded in international trading. What I'm trying to say, the international trading is driving the greenhouse emissions, but the greenhouse emission is a symptom of the intensity of the extraction of the raw materials, because the raw materials has been extracted in countries that they don't have the capacity to replace the old technology and reduce their own and carbon footprint. Here you can see in yellow is in orange is the greenhouse emissions by productions, and sorry, let me remember that. Yes, in orange is the greenhouses and emissions by extracting materials, exporting goods, and in the blue one is the greenhouses emissions by importing goods. Just like reference, if you add all bars in orange, the exportation have a higher carbon footprint than the importing goods. So this kind of and the international trading is showing that right now a huge quantity of the greenhouse emissions has been producing in countries with an old technologies extracting raw materials to in countries exporting and too many products and to the global north and rich economies, and by using old and technologies in transport and so on. So, and if we need to understand, for example, the consumptions and the greenhouses and driven by consumptions in developing countries. Here you can see that you have two kind of perspective. The perspective from the productions of the consumptions, and here's in this balance, when we have current emissions and previous emissions, you can see that right now the main drivers of the emissions and the main drivers of the environmental impacts is based on the consumption, and the consumption is based on the rich countries but not in the global north. So the apparent problem is how we can circularize the economy, but the real problem is we are not providing the right solutions to circularize the economy in the countries producing and exporting raw materials. So in the circular economy approach, we have a use of the new resources. Go to the manufacturing countries. The manufacturing countries distribute and produce the services, and the final destination are the glove in different parts using the good. And in this place, we need to try to promote the reuse, repair, refurbish, and remanufacturing. And finally, at the end, we can promote the recycling. But the problem is the take back. The take back is easier for the most developed economies, but has not been very well in the most vulnerable countries, because the take back is a key step to recover too many materials and reintroduce into the distributions and services, specifically, for example, for electronics, for example, electronics. So we need to reduce in all of part, we need to reduce the materials and try to refuse the excess of the quantity, and maybe in some specific part of the circular economy cycles, we need to produce, repurpose the different resources and so on. Indeed, if we can recover the goods in different parts of the world, we can propose, repurpose, repair, manufacturing, and so on. So if we reduce that, we can reduce the extraction of the raw materials. So suppose that if we are extracting in the developing countries sand, oil, gas, land, and water, finally we are producing too many minerals and ores that are going to the productions. The production is responsible for the design, the materials, components, modular systems. They are responsible for the distribution throughout the world. The consumers and the end of use. And at the end of use, we need to invest in the most vulnerable countries in the collection, sorting, and disassembly. At the end, we can promote in the global south recycling, recovery, and remanufacturing, and maybe reuse, repair, and refurbish to try to connect them to the distribution and services. And finally, we need to incentivize to the main economies to incentivize to support the product design for circularity. Finally, we need to enable producers to increase their sourcing to recycle materials. And we need to encourage the consumers in participate in bring back schemes, set up effective content recovery and collection systems, strategically plan and install sorting for processing and recycling operations, and increase the incentive for investment in recovery, collection, recycling technologies and facilities. This is my last slide, and what we need to try to avoid. This one. So, what is the final message for this slices on physical economic challenge within a global supply chain framework is we need to understand that the consumption is driven by the rich economies. They are manufacturing too many products and exporting these products to the global south for the rest of the consumers. And the problem is in the most vulnerable countries, they are receiving a lot of impacts of the climate change because they don't have money for adaptation to try to face the climate hazards. And additionally, they are receiving the impacts by the increasing the extraction of raw materials, but they don't have the capacity to recover our materials or recover food and so on. And they don't have the capacity to return this kind of products for the manufacturing economies or for the factories, for example, at the South of Asia. So the main challenge is how we can understand the trading between different countries, linking the productions and consumption to try to reduce environmental outcomes and in the beginning by extraction, and how we can return in this kind of materials to propose something in the next conference of parties, because finally when we are talking about adaptation, the final objective of the adaptation is try to keep the economies and working very well in different regions. And some economies that according to the projection that we have is some economy the destination of the specific economies and the global south, and the global south, the destination is increasing the poverty. So this is the big and goal of the discussion, and invite my colleagues to discuss about the material flow accounting, about the environmental outcomes through the supply chain, and how we can and circularize effectively different economies, connecting producers, manufacturing economies, designers, and the global south. Thank you.
Thank you very much, Professor Godoy, for such a thought-provoking and a comprehensive talk, and also for giving us insights about circular economy challenges within the global supply chain. Before we move to the panel discussion session, we have a polite request for our attendees. We would like to capture a group photo with all of you at the end of the panel discussion. Since we are conducting the session in a Zoom webinar mode, it comes with its own set of advantages and disadvantages. To ensure that everyone's videos are visible, we'll need to promote each attendee to the panelist role. We will assist in promoting you as panelists towards the end of the session for the group photo, and we kindly ask for your cooperation and understanding. Thank you very much, everyone. Now, let us proceed to the panel discussion. Allow me to introduce our esteemed panel members for today's session. We have Professor Ekla Khan from the Department of Civil and Environmental Engineering and Construction at the University of Nevada, Las Vegas, USA. Professor Khan actively works in the fields of environmental contamination, the fate and transport of contaminants in environmental media, and water resources management for the water-stressed Western United States. Next, we have Professor Jorge Gomez Parades, who is a professor and researcher on energy transition at Novia University of Applied Sciences, Finland. He is also the managing director of UN Sustainable Development Solutions Network, Andes. He is also an adjunct professor at the Earth and Climate Sciences Division at the Nicholas School of Environment, Duke University in the United States. We also have Dr. Jonathan Lee, a senior research fellow from the Environmental Research Institute of the National University of Singapore. His research interests include environmental microbiology, life cycle assessment, bioaugmentation, sustainable development, among others. Now, we will get started with the panel discussion. The panel discussion will go for about 20 minutes. We also request our attendees to post their questions freely to the chat box or the Q&A tab, or raise their hands using the raise hand function on Zoom to ask a question to the panel or discuss something with them. Over to you, panelists.
All right. Any questions? I'll start it. I'm sorry. Go ahead.
No. Please go ahead.
I would like to start by thank you, Professor Godoy-Faúndez. Very interesting talk. I learned a lot. I always like all these facts and numbers, and what you said is true. Sometimes we're looking at things one way, we don't look at things in a different manner. And when you look at things in a different manner, it's kind of eye-opening about this export and import. So thank you, for bringing in some of these new dimensions to our attention. So that's how I would like to start the panel discussion.
Yeah, also I would like to join in those words. I think it was a very comprehensive talk and showed us many aspects related to circular economy and actually the challenge. So perhaps we can start talking about some of those challenges, right? And if I may just drop something on the table right now, I think that I see a lot of these movements or these initiatives to make circular different production sectors and so on. But I don't know if we are really looking at the global economy, which is what I think Alex was showing us. All these connections from producers in one part of the world with consumers in another part of the world. Can we make circular that? To what extent that's possible, and what does that imply? For example, Alex was talking about how many of these countries that are producing are in the so-called global south, that is more prone to disasters, and they would require huge investments not only to be able to be part of this circularity, but also to adapt to climate change and make sure that they don't, that there's not a problem there that disrupts entirely that supply chain that now will be part of the circular economy. So anyway, let me drop that there and continue conversation with the rest of you. Perhaps Jonathan?
Can you hear me, sorry?
Yes.
Yes, okay, great. Yeah, thank you, Professor, for the really great, interesting lecture with a lot of the facts and figures. So without rehashing all the points that have been raised already, I was thinking like one of the main points Professor Alex was raising is that there is a huge disconnect because of the amount of money that the Global South does not have. For example, in terms of being able to adapt to the renewable technologies, right? So just off the top of my head, I was just wondering if, something like the carbon credits, like it's been debated quite a bit, but because of the carbon emissions that are embodied in these products, like would it be conceivable that we can use this additional pricing to help negate some of the costs that are involved in this recovery of the materials?
I have some troubles with my games. So, and yeah, so sorry. Can you repeat that because something happened with the. Can you listen to me, no?
Yes, I can hear you.
Yeah.
You can hear me all right?
Right now here, yeah. I
Okay,
couldn't
right.
listen you. Yeah.
Right, sorry. So I was saying like one of the key points that you pointed out was that how the global south has to bear the burdens of these material recovery, and that they are quite there's quite a bit of a setback for them because they don't have the money to help in the transition to adapt to renewable energies or technologies, right? So I was just wondering, excuse me, sorry, I'm not feeling very well. Like I know that the carbon credits, they are quite debatable, but would it be an a point that helps to recover some of this cost because of the carbon emissions that are embodied within these materials? Would it help to defray the cost, at least in terms of the material recovery, to assist in the circular economy for these countries?
Yeah, but you say I think has been very complicated because in the climate change, well, sorry, in the conference of parties, one of the main discussion is how much money the rich economy needs to put on the table for the middle income economies and low income economies. But the question is on how much money for what? Because when we are talking about the adaptation to the climate change, the idea is try to invest in reduce to the vulnerability of these countries against of the climate hazards. But the climate, but my point or the point of the too many economists and engineers is if suppose that if we need to invest $1, is what could be your criteria to invest $1? And finally, the problem is that we are understanding that maybe we need to invest $1 to try to keep the economy healthy in the most vulnerable economy. What I'm trying to say that suppose that if we are importing, if I am living in Europe, I am importing food from the Ecuador, yeah, the country of my colleague and Jorge. So the problem is maybe the intensity of the consumption will drive the environmental outcomes in Ecuador because they're using more fertilizers, they're trying to extract more water and so on. So, and yeah, I need to invest $1. I need to invest $1 to increase the energy efficiency in the housing in Ecuador, or I prefer to invest $1 to reduce the vulnerability into the farmers and to keep the farmers healthy against of the climate change, because the climate change is for one side, but finally the intensity of the farmers and productions depend of the demand. Is the similar for the United States. The United States right now has a strong competition against Europe for the electric cars. Indeed, the IRA is at $300 billion to try to recover the economy in United States and doing a reshoring of the too many factories, investing in too many and in too many and companies there. But the problem is we have right now three main economies, China, Europe, and United States for the same raw materials, lithium, copper, and rare minerals. The question is, who is paying for the environmental outcomes leaving behind? And if we need to invest $1 for adaptation, how we can decide the criteria for that? This is the open discussion, because and Khan is located in United States, and he knows that finally they need too many raw materials importing from the South, but nobody thinking that if the industry in the global South collapse, the flow of the material flow between global North and global South is not safe, because the interest in the industry will be collapsed, because they need more water, they need more energy, and so on. And the intensity of the greenhouse emissions depend of the old technologies, and maybe the Ecuador, the farmers there is the similar situation. The farmers in South Africa, in Morocco, they don't have money to replace one truck. They are not buying the next hydrogen truck. So this is the discussion that we need to try to show for the next conference of party, because suppose that if we are recovering lithium, how we can return the lithium for United States? United States manufacturing batteries? Maybe not. It's manufactured in South of Asia. Who is responsible for that? Who is responsible for the secularization? So this is my question for you. This is my question. It's so beautiful to talk about the circular economy, but nobody's talking about who will be the responsible. What are the secondary markets to secularize the globalization? Sorry, Jorge.
Thank you. I just wanted to take some of what you said and also add something. Well, in your presentation, you said it. Circular economy is the main approach, or one of the main approaches now to reduce greenhouse gases and to have climate action. Yeah, but then we are assuming that by making this process circular, we are actually reducing energy and emissions, which I think it has to be calculated and put into the test. But anyway, before we get into that conversation, as you said, the issue is that, say, the so-called global South, right? The emissions from the global South are high and rising. So if this is going to be a main strategy to reduce emissions, then we need to include, as we say, the global South and this circularity. Also because, as you said, they are key parts of production nowadays, so they must be included. And that's a big challenge of a global circular economy, how we include these countries. Because, again, to the point I was trying to make before, these countries would require technology transfer, of course, knowledge and so on, funding to create the necessary infrastructure and processes to be part of the circularity. But at the same time, these countries that, as you said, are more prone to disasters, they require funding for adaptation, to make sure that there's no, as you said, there's no disruption in this global circular circular supply chains, in a sense. So that's a lot of funding and a lot of technology transfer and a lot of things that I don't think we are seeing. At least I'm not seeing. I'm seeing that the global North, so-called global North or industrialized economies, are going into circularity looking within, but not really looking outside. And I think that's the main challenge. Also, there's an issue and maybe we can also discuss this or expand a little bit more of this, if the global North circularizes, I don't know if that's the term, or makes circular most of the processes, to what extent will not depend from the global South. We will create some gap in those economies, in a sense, and then what will happen with employment in the global south? That's another issue, I think, that we could discuss. So to me, these are the big challenges, or some of the big challenges of a global circular economy. Investment in those countries, poor countries in a sense, and technology transfer and so on that we are not doing, and this idea of expanding these circular strategies to the whole globe. Let me stop there.
I think, you know, the discussion here is really, really wonderful. I think we're looking at a scale issue here. You know, circular economy, you know, works really well, you know, when we look at a smaller scale, you know, when we practice something at a smaller scale. But when you're looking at what, you know, Alex presented, is much more complicated when you're dealing with material flow, energy flow, and things like that. And should we tax, you know, rich countries? I agree in general, yes, but in the end, what's going to happen with that money? How is that money going to be used? And we still have issues, right, with some middle income and lower income countries in terms of like, yeah, okay, let's throw the money. What would happen there? We have to face with what? Enforcement, corruptions, all kinds of things. I mean, you know, there's no, it's not going to be an easy solution to the problem that we facing here. I think, you know, like in the US, we have what is called, and I think this is the same concept that can be applied. It's called environmental justice. Why all these dump sites and all these areas that have environmental problems are always in, like, you know, poor neighborhood, or because sometimes we use the word minority, economically disadvantaged, a minority neighborhood, you know, you know, these contamination never occur in like rich neighborhood and things like that. And we call this issue environmental justice. And this concept of environmental justice can also be applied globally. And the way the US is handling environmental justice within the country is not throwing in money. We're not throwing in money to these communities straight like that, but we try to work with them. You know, we're trying to go in all these communities that get affected, you know, these communities that get affected from contamination, environmental issues, because they tend to get affected more in general anyway, because they don't have the capacity, they don't have the infrastructures. You know, the list that Alex gave about, you know, who get affected, you know, homeless and things like that. Another thing that, you know, that should be added to that list is probably rural communities, because rural communities are not equipped. You don't have the infrastructures and things like that. So the way it works is that it requires cooperation among countries. That means, you know, if all these rich countries are really sincere, you got to go into this smaller countries, poorer countries, go in there and work, not just throwing money, but go in there like the way you do it in your country. This environmental justice is go and try to build adaptation, mitigation, and come up with projects, working together. You know, throwing money, it doesn't work. You know, and where is that money gonna go? How money is gonna be used? I think it involves sincerity and cooperation. And it's going to be a lot of work when you deal with multinations here. It's not going to be an easy solution, but I think it's doable. It's just a matter of bringing all these countries together, you know, get a clear picture of what's going on and working together. You know, tax, you know, credit, well, carbon credit, it works, but you know, it has to be beyond just simple, you know, simply, you know, throwing money to these countries. So we're dealing with a scale issue, like I said, very complicated. It's not that easy, but there's, you know, there's always a way. You know, I would like to respond to there's a post in the chat. I'm sorry, I'm, you know, running a little bit long here. About lithium, you know, what we're gonna do. I mean, what we're facing right now is not unusual, right? It's been historically this way, that, you know, we always, you know, try technology first. We adopt technologies without thinking, okay, about environmental impact, about solution, like how we deal with pesticide like DDT in the past, how we deal with PFAS, right? We invented plastic. You know, these things make our life better. We have to agree, right? These things make our life better. But, you know, after what certain number of years, we realize, oh, PFAS is bad, plastic is bad, you know, DDT is bad. We banned DDT in the US and things like that. I mean, it's always that same, you know, same story over and over again that we always adopt technologies, we always adopt chemicals, we always adopt materials before knowing enough about their impact. And lithium is the same thing. It's no difference here that, we start mining lithium in different places in different ways and be careless. By the time you know something, it's never too late, but it's always behind. The environmental remediation, environmental issues always behind, investment and money and profit. Is it normal? It is normal. That's the way it has been, and that's the way it's gonna be. I can give you another example. If you look at research funding in the US, my colleague in materials, okay, would get $1 million type of grant versus the same issues related to that, the same environmental issues related to that material. The level of funding is about $1 million or $2 million. There's no comparison. It's not an equal playing field that we're talking about here. It's not even. Always environmental is always behind. We're always catching up. We're always playing that catching up game, right? So, I just want to leave it as that. So that's my 2 cents.
Jonathan.
Yeah, so I think this is an excellent place for me to chip in on that. So while there is a lot of discussions about the downstream effects of the technologies that are new, so these are things that we need time as well, I think, for research to figure out. But one step before that is that what I think would be very useful is to be able to look at least the environmental impacts of the different products that, let's say, we are considering. So that is where some of my work in life cycle analysis comes in, right? So this takes a very it considers the global impacts because we will trace the materials as well as the energy flow, usually all the way from the cradle, which is where the product is being produced, all the way to the grave. So what is this end of life scenario for it? And it is an extremely tedious process, and my collaborators don't get enough thanks for it. But I think this is something that is very important because it helps, at least let's say for consumers to decide, based on this life cycle analysis, how much of an impact on the environment I'm having with my choice of these products. So of course, I'm coming at it from the E side of the ESG, the environmental side, but there are so many other things that could be analyzed using that same life cycle analysis framework. For example, the life cycle costing, right? As well as even the social impacts, right? So I think what Prof. Khan was also referring to, like how does these products, or the manufacturer of it, how does it impact the communities that are around? How does the trying to produce it? What are the does it cause like things like deforestation? Does it cause homelessness if you are driving traditional people groups out of their places, right? So these can all be examined using a life cycle framework, and of course it's not an easy task. And so here I'll just put a shameless plug. I have a seminar on this coming Friday afternoon where I look at how cellulose bioplastic could be used as a replacement for fossil fuel-based single-use plastics. And if you're interested, you can contact the APRU. I'll send them the details for that. Thanks.
Yeah, that's true, and I would like to and take two notes from Ken, and one is about the responsibility of the middle and low income countries about the corruption and so on, because this is once Franz Timmermans in the Sharm el Sheikh and put on the table. if we are putting $100 billion, we need to try to understand if the countries are fighting against the corruption or so on, because it's not the same to put on $1 to invest in reduce the vulnerability if the countries continue to be corrupted. Sorry, but this is true. And about Jonathan, you say, yeah, always when you're talking about the life cycle assessment, we are talking about the life cycle assessment and environmental life cycle assessment. By the life cycle costing and the social life cycle assessment will be key to understand about what could be the distributional effects of environmental impacts in the supply chain, specifically when we are trying to deploy in different and circularization process to try to reduce the impact of the global supply chain. Jorge.
Yeah, thank you. Well, I also wanted to comment on some of what Ken said and Lee said, well, and now you said. On the one hand, well, very briefly on what Ken said, I totally agree that a global circular economy requires a global partnership, and it's not only about funding; it is about working together for sure. So that's I agree with that. What Lee said, okay, life cycle assessments, I do input-output analysis, so it's very similar for footprint assessments. And what we do is, yeah, we have to, in order to calculate a footprint, as you know, we look at the impacts throughout a global supply chain. And this is why I said, we need to put some numbers behind this idea of circularity. We are all, I think, we all agree that a linear economy is unsustainable. That's for sure. So making it circular makes sense. Of course, we cannot make it perfectly circular. That's impossible. There will always be some input and there will always be some output in the sense of emissions and waste and extraction of energy and materials from the environment. That is not possible to make it perfectly circular, as some very nice graphs sometimes are used to explain the circular economy. But anyway, it makes sense. That I agree. But what I see is that many times we assume that if we make something circular, we, by default, must have reduced emissions and energy, for example, or material consumption. And that may not be so. I think because we talk about, for example, reverse logistics or reverse supply chains, right? Or bringing the end-of-life product back to the producer and so on. All that consumes energy and will generate emissions. If by circularizing the process, turns out that the whole energy and emissions footprint actually is reduced because we now extract less and so on, great. But it has to be put to the test because I just don't see, I think that if you bring a product that you produce in one part of the world and you send it to another part of the world to be consumed and now you bring it back and passes through another process, it may happen that you are actually emitting or consuming more energy, I think. So this has to be calculated with life cycle assessments or input-output analysis or any other methodology you want, I think. That would be my input.
Yes. Guess we are running out of time. Professor Khan, would you like to comment at the last?
Well, just a quick one. I mean, all the panelists, I totally agree. See, what we're talking about, what is going back to this, smaller country and poorer countries. What is going back right now? I can give you an example. Okay, the electronic waste. What is going there is waste. Waste that is dangerous, that could be harmful to people. That's what is going back, and it's not fair. And as long as we still practicing this waste export, toxic waste export, electronic waste export, we're not going anywhere. That has to stop. That's not the right thing to do. So that's what is going back right now.
Right, indeed, Professor Khan, this is the same discussion that we had in Ottawa for the plastic treaty about to avoid or reduce the plastic pollution. It's the same question that you are mentioning. Because finally we don't. One of the main questions after the treaty has been we need to understand the material flows. What kind of the countries are the producers? What kind of countries are the importers? And what is the responsibility between the importers and the producers? And because finally in the plastic, maybe it could be worse, because all people is thinking in the plastic for just one uses. But the another things is we are thinking in medical devices, or for example, plastic for fish, for fishermen, because it's so hard to try to reduce and the net used by fishermen. So that you say is a key question that in my opinion, and according of my knowledge, and the main challenge of the circular economy is not the methodology for the circularized economy, is how we can do that in a global supply chain, understanding the trading, the drivers by consumptions, and what is the responsibility of the different actors throughout supply chain in food, minerals, and so on. This is my last word.
Yes. Thank you very much, panelists, for an engaging discussion, and Professor Godoy for also answering the queries posed by our attendees. Now,
but
we request
Jorge Josan say something.
No, it's okay. If we run out of time, I think we'll leave it there. But I thought just wanted to very briefly say what you were saying about looking at what the producers, the consumers, and so on, is also looking at who pays the cost and who gets the benefits of a circular economy. There's always, impacts are not equally distributed, of course. So some people are more affected than others, and some are more benefited than others. This has to be very clearly analyzed as well before we call something a solution. Thank you.
Thank you. Now, we request your understanding for capturing a group photo. Our team will assist you in promoting as panelists. Please bear with us for a minute. Give us a few more seconds. We're almost done. Yes, we are almost set and have promoted most of us as panelists. Our team will assist in taking a group photo. Okay, 1, 2, 3, smile. One more. Smile, please. Okay. Thank you, everyone. We have now reached the end of the session. And before concluding the webinar, I thank Professor Godoy, our speaker for today's session, and our panelists for the valuable insights and for engaging in the audience to an enlightening discussion. I thank all our attendees for their active participation. We extend our special thanks to the APRU and the APRU SWM program led by Professor Young-Shik Ok of Korea University for organizing these events and creating a learning and networking platform for students, researchers, and everybody. We request you to look forward to our upcoming sessions too. The next session is on July 16th on Sustainability in Higher Education by Ms. Bonnie Benson of the University of California, Los Angeles. Thank you once again, everyone. We hope you all have a great day ahead.
Thank you. Bye-bye.
Bye-bye. Thank you.